Hello, this is Professor Kyle Mack. You are watching 12-1 Lesson Intro in 5 minutes or less. The first major thing that we're going to look at is congruence and similarity. Congruent figures are figures that have the same measures for their sides and their angles. Similar figures only have the same measure for their angles. One way of thinking of this is congruent figures have the same shape and the same size, while similar figures only have the same shape. So the picture that we have here, these two triangles are congruent because they're both the same size and shape. But if I were to take this triangle right here and I were to shrink it, it would be the same shape, but it just wouldn't be the same exact size. And so therefore they would be proportional to one another, which is something we'll look into with similar figures later, but they are not congruent to one another. The next thing is whenever we name these things or state that something is congruent to something else, we have to name them in an order that tells us what the corresponding parts are. So for example, A corresponds with F. So I can't name this triangle ABC and this DEF because they don't correspond. I have to call it triangle ABC is congruent to triangle FED. All right, now we're going to look at the parts of a circle. There are two major categories of the parts of a circle. There's the arc and the chord. And we have minor arcs, which are less than 180 degrees of rotation from the center. We have the center of an arc, which is the point that is equidistant to all points along any arc or circle. We also have the major arc. That is any arc that extends from 180 and then up to 360 degrees. And then you've got a semicircle, which is 180 degrees of rotation around the center. And then when we name these, we actually have a naming system so that way people don't have to actually see the circle when we name them to know whether they're minor or major. And so we use only 2 variables to name a minor arc, and we name 3 variables to name a major arc. Okay, then we have the concept of chords. Chords are more like lines, and so or line segments arrays. But what we have is a chord is any line segment that is connected between 2 points that lie on a arc or the entire circle. Then we also have the concept of a diameter, which is a special type of chord. It's connected by 2 parts, but it also intersects the center of the circle or arc. And then finally, the radius is half of the diameter and is defined by any line segment that extends from the center to the arc or the entire circle. And then we also have some of these concepts of tangent and secant, but we're not going to look at those for this particular lesson. All right, now we have triangle congruence properties. Those are side, 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 angle, side, angle, side, angle. We're going to do a lot of work with these. So the only thing I really want to talk about is if you can basically, if you can find out that 2 triangles have any of these relationships with one another, then you actually are proving that they are congruent. So any triangle that has the same measure of all 3 sides to another triangle is congruent to that triangle. All right, and then we have rules of Euclidean geometry, or just Euclidean geometry in general. But the major thing we're going to look at in this lesson intro is just the rules. And so basically it's just drawing shapes, but you can only use 2 tools. And that's the last rule here. You can only use a straight edge and a compass. So by using a straight edge or a compass, and I do it a picture of a ruler, but you can't use these graduated marks on the ruler. You can only use the straight surface to sketch lines, line segments, and rays. So the major rules are you can only 2 points will always make a unique line, meaning no other line can be made from those 2 points. Lines can always be extended in either direction. Circles can be created using a center and a radius. And you can make any points on any line segment, line, or circle, so you can just arbitrarily choose points. With these rules in play, you can actually create just about anything you'd like, and you can even determine congruence, and you can determine angle measure using the Euclidean geometry principles. And then in class, we're actually going to look at all of the listed constructions, and I have pictures of them up here on the screen. That concludes your 12-1 lesson intro.